Good evening, everyone, and welcome to class again today. Want to say welcome, and we are wrapping up this topic today with TCP IP suites. And basically, we're going to be configuring and setting up SSH configuration on a Cisco router. And if time permits us, we could look at also setting up on a Cisco switch. So what is TCP? We've actually looked at this extensively, but it's important that we grab this basic understanding of what TCP really means. So in today's class, we will have an overview of what TCP IP suite means, because understanding this suite is an important aspect of IP networking that every IT professional must understand. It's an important aspect of IP networking, and it's very crucial for anybody who is going into the IT or the tech world to understand what basic TCP IP suite, what it simply means. Let's dive in. TCP IP suite, which is transmission control protocol, internet protocol. It's the fundamental set of communication protocols. If you'll be following our class, you will discover that we've looked at common network protocols such as DHCP, we've looked at DNS, we've looked at FTP, we've looked at HTTP, we've looked at HTTPS. We've configured all of this. You could go through our series of videos that we've done, and in the last class, we set up all of these common protocols on a stretch using the Cisco Packet Tracer. Tonight, when we are done with TCP, the only protocol that we still want to mention about or we will discuss about is SSH. And we're going to be using the same topology, but now we're going to be configuring SSH on top of these common network protocols. So it's the fundamental set of communication protocols used on the internet and common modern networks. It consists of 4 layers that defines how data is transmitted, routed, and received across networks. What does it do? It consists of majorly 4 layers. Remember when we talk about our OSI model, we said, oh, it has 7 layers. Later on, we moved to the TCP IP, and we said it has 5 layers. We move across everything, but TCP IP suite, we said it has what we call the 4 different layers. And what are these layers? The first layer is the application layer, which is responsible for communication between applications and includes protocols like HTTP. We've configured HTTP, our web server. FTP, we configured that as well, file transfer server, whereby we can copy configurations from our routers, copy configurations from our switches, and save it on this server. And anytime we need it, we can retrieve using the put and the get command on our PCs once we are able to log into the server. SMTP, which is for our emails. And common protocols like HTTP, that is the common protocols that works in this application layer, is our HTTP, HTTPS, FTP, SMTP, DNS, SNMP, SSH, etc. These are the common protocols that works in this layer. The second layer is the transport layer. We said this transport layer manages end-to-end communication and provides error checking, data flow control, and retransmission. And what are the 2 key protocols here? It is the TCP and the UDP. TCP, Transmission Control Protocol, and UDP, User datagram protocol. Internet layer, we've discussed this before as well. We said it's responsible for the logical addressing and routing, ensuring that data packets are sent from the source to the correct destination. And what are the core protocol here? It is the internet protocol, along with others like ICMP for diagnosis. Now, when we talk about ICMP, our ping, our trace route, and ARP, which is address resolution protocol. And the fourth one is the network access link layer. This handles the physical transmission of data over the network, like internet or Wi-Fi. It ensures that data is properly encoded and transmitted over the media. Now, I want to look at the TCP versus UDP. What is the distinction or what is the differences between TCP and UDP? Both TCP and UDP operate at the transport layer and are used to send data over a network, but they have different characteristics, different features. We are saying that the TCP and the UDP, they are both a protocol that operates at the transport layer of the TCP IP suite. However, they have different features, different characteristics, and the things that distinguish them from one another. Now, what is TCP? Transmission Control Protocol. One of the first and the most important part of the features of TCP is that it is connection oriented. What do we mean by connection oriented? It makes sure that, okay, the two communicating devices acknowledges that we are going to be talking to one another. So we call it three-way handshake. So what does it say? It said TCP establishes a reliable connection before sending data. That is, it's going to say PCA. If PCA is sending a data to PCB, before it starts transmitting that data, it says, hey, PCB, are you there? PCB is going to respond, yes, I am here. Okay, fine, I can send my data now. So it starts sending data. So it requires a three-way handshake to set up the connection. So it says, hello, are you there? PCB will respond, yes, I am here. Then you will not respond, take the data. That is the three-way handshake. First is the data that the hello, more like a confirmation message being sent to PCB and saying, oh, I want to send you some data. So tell me if you can receive the data. And PCB say, yes, I can. And once it says, yes, I can, it sends the data across. So the first characteristics is connection oriented. It's ensure that there is a connection between the sender and the receiver before data transmission takes place. Number two characteristics or features of TCP is reliable. TCP ensures data integrity by guaranteeing that packets are delivered in order without loss and retransmit if needed. Now, in other words, if for instance there is the connection between PCA and PCB is wireless and something happens, maybe there is an interference during the transmission of the packet, and maybe out of 10 messages that was sent, only 5 got delivered. PCA is going to retransmit the 5 that did not get delivered to PCB. So that is what we are saying, that it's a very reliable protocol in terms of ensuring that all sent data are being delivered. So the third thing is flow control. TCP manages congestion control and flow control to avoid overwhelming the recipient. When we're saying recipient now, we're talking about the receiver. So it's going to ensure, okay, have you gotten A? If he has gotten A, before it will send B, before it will send C, before it will send D. This is not the case in terms of UDP. So TCP manages flow control manages congestion, ensuring that there is no overwhelming or overload on the recipient or the receiver PC. Use cases: application where reliability and data accuracy are crucial, like web browsing, which is HTTP and HTTPS, email, like our email, file transfer, and remote logins. This uses TCP. They uses TCP because you expect that if you are sending an email, you don't want your email to just go without being delivered to the recipient. So that is why it is important to use TCP protocol in order for these kind of services to. So when you are looking at for a service whereby what you prioritize is reliability and data accuracy, then you consider using TCP and not UDP. What are the key features of TCP? Number one, ordered and reliable data delivery. In other words, it ensures that data are transmitted and are delivered successfully to the recipient from the person who is sending it, from the sender. Error detection and correction. It detects errors and it corrects them. Retransmission of lost packet. That is, if there is a lost packet, it's going to retransmit that lost packet, ensuring that every sent data is received by the recipient. Flow and congestion control. These are the key features of TCP. Just understand this, that it is connection oriented, it manages or corrects errors, it retransmits data, and also manages congestion. In what use cases do we use TCP? Web browsing. We use it in web browsing. We use it for file transfer protocol. We use it for email. And likewise, I said we use it for SSH, which is what we're going to be setting up tonight in few minutes. UDP. What does UDP does? User datagram protocol. So this also, we said both UDP and TCP operate at transport layer. However, they have some different features. So we said the first features for UDP is connectionless. So it's just like the opposite of TCP. Connectionless. The word connectionless does not mean that it doesn't even have connection in the first place. But it does not establish, it doesn't say, first of all, say, oh, are you there? Are you ready to receive my packet? Now, UDP send data without establishing a connection. So remember in TCP, we said we have three-way handshake. You say, hello, are you there? And the receiver responds and says, yes, I am here. Okay, I'm going to send you data now. But TCP is not going to, first of all, UDP rather, won't confirm whether you are there. It just sends the data. Meaning there is no guarantee that the packet will arrive in order or even at all. So it's unreliable but very fast. So UDP does not guarantee delivery, but it has low overhead, making it faster and more efficient in certain situations. So we are saying that UDP will not tell you, oh, I'm not 100% sure if it's going to be delivered. However, I am going to quickly get your job done for you. If you don't mind, if it won't be delivered, no problem. All right. No flow control. There is no mechanism to handle congestion or ensure that data is being received. So there is nothing that is going to tell us, oh, if data is received or not. Use case. Applications where speed is more important than reliability. Are you seeing this now? So now, when you are considering speed as your priority, you go for UDP. So for instance, you have some infrastructure set up in some companies. They set up their infrastructure to prioritize availability more than security. So when you prioritize availability more than security in some organization, you might not bother about firewalls. You just set up your routers, use maybe access list, and that's all. But when you prioritize security, you begin to look at setting up firewalls, setting up some. So you are not saying, oh, everybody should be able to access the data or access a resource. You want to be sure that the right person is the person who is having access to the right resources. So we said application where speed is more important than reliability, like streaming, online gaming, VoIP, voice over IP, and DNS lookup. These are the kind of applications or the use cases where UDP is being used. Key features of UDP: lightweight and minimal overhead, faster but unreliable, no acknowledgement or retransmission. So if a packet is lost, it's not going to retransmit it. It's gone. No guaranteed order. In other words, it's not going to tell you that, oh, I am able, it's not going to say, I send A first. A to deliver first. So it's possible for you to send A first, send B, send C, and somehow, C is going to be delivered before B or A. So that's what we're saying. So there is no guaranteed order. So example use cases of UDP is live video or audio streaming, such as YouTube, Netflix, VoIP, DNS query, online multiplayer games, and so on. What are the key features? I'm going to send this PowerPoint to us at the end of the class. Just remind me, as soon as I post the link for the post it on YouTube, you can get access to it. So, connection type: TCP is connection oriented, while UDP is connectionless. Reliability: TCP is reliable with retransmission. In other words, it can retransmit any lost packet. UDP is unreliable, no retransmission. Error handling: TCP does error detection, correction, and acknowledgement. No error handling with UDP. Data ordering: data is sent in order. That is, A goes first, B follow, C, and so on. No guarantee of order. Speed: slower due to overhead, because it's slower because it wants to be sure that it gets to where it's going to, but faster due to low overhead. And use cases: web, file transfer, email, SSH, etc. in TCP. And under UDP, we have streaming, we have gaming, we have DNS, and we have VoIP. So these are we come to the end of TCP and UDP. So let's try to set up our Cisco packet tracer and set up our SSH. Do we have any question? Because we want to go to configuration now. Is there any question regarding our TCP and UDP before we move on?
Um, Good evening, sir.
Good evening, great man.
Um, Actually, thank you so much, by the way. I have a question regarding UDP and TCP.
Please go ahead.
So while you were discussing about, so I want to know which of the two is like, what's it called? WhatsApp are they using for the
Oh,
app?
okay, so when you want to say WhatsApp now, there are different things, there are different applications that runs even on WhatsApp. Are you talking about text messages or voice? So if you are looking at,
I'm talking about sending of data.
okay, so if you are sending messages, remember that you are sending text, message, and so if it is message, you should see that that is going to be TCP. But if it's going to be voice call, that is definitely going to be running on UDP. You know, sometimes you won't even hear what the person is saying. He say hello, hello, somebody is singing. You can be hearing the same thing three times. Maybe you didn't hear the first part. So that is, he's not going to first of all confirm whether you are there before he starts sending those messages to you. So if it is the voice call, definitely that is UDP. Do you get that?
So right now, as we are on call, right now, we are using UDP.
We are using UDP. That's it. It's possible for you not to hear some of the
Thank you
things
so
I'm
much.
saying. If your network, maybe your
Exactly,
data just
it's
go
kind of
off at
important.
some time, when you come back, it's not going to transmit what I have said when you lost connection. Do you get?
Yes, sir. Yes, sir.
Okay, so if for instance I lose my internet connection here and I keep talking without knowing, and all of a sudden I come back online, all what I've said has gone into the thin air. You won't hear it. You will just say, ah, sir, I lost you for a moment, right? I lost you for a moment. Now, you will now say, can you repeat yourself? I will have to repeat what I have said. But what you are going to be hearing is not what I said the earlier time. That one has gone into the thin air. But if it is TCP, even though I go off, once I come back, it's going to retransmit it. So for instance, email. Remember our TCP works with email. If I send an email and I don't have internet, maybe as I send the email, I shut down my laptop. The mail has not dropped at the recipient place. Now, I shut down my laptop. Immediately I power on my laptop and there is internet connection on my laptop. What will happen? The email will drop, right? The same mail that I sent, because that is TCP.
All right. So on WhatsApp voice notes right now. So WhatsApp voice note they are using TCP as well. Is that correct, sir?
Voice note, if you use voice to record, yes. But if you are doing a direct voice call, that will be using UDP. So
Yes.
they
Yes. All right,
integrate
sir.
both protocol. So you can use the two protocol depending on the kind of application or the service that you want to implement. Do you get that?
Yes. Yes, sir.
All right, thank you. Any other question? Okay, so if there's no question because of our time, let's quickly look at what we've set up before, because we are just implementing SSH on these protocols. We said we've discussed uh, FTP server. This is our LAN router. We've configured it before. We have HTTP configured, DNS configured, DHCP configured, and they are working fine. But now we want to configure SSH. Why do we want to configure SSH? We don't want to always, anytime we want to configure this router, we always go and click on the router. We don't need to be doing that. We're supposed to have a remote section. What does SSH does for us? SSH helps us to have remote connection to our routers, remote connection to our servers, remote connection to our switches. That is what SSH does for us. Are we here? So if I come to this PC, I should be able to log into the router using SSH. So SSH, maybe maybe I have a user called admin and 192.168.30.1. It's asking me for password. That means it's possible that, oh, maybe I have an SSH configuration already set up on this PC or on the router. So let's go and check. If we have, we will just have to check some things. So let's look at the router. Enable. So it's asking me for password. So I guess something has been done. But let's see. We will do something. Show run. Show run. Okay. Okay, so what we do is to set up something very quickly. This has been set up. So let's open another topology and set it up from there. I want to start it afresh for us and so we can have it running. Let me see this DHCP configuration and let's see what we have running there at the moment. So we are going to use the same topology that we have set up before, and that's what we use to set up our. Okay. So let's see if, let's use this topology. We have 4 users here. So we said that the purpose of our SSH is that we don't want to always run into this router to go and configure it. using the router interface. Show run. Let's see if we have SSH running on this. No, there is no any SSH here. Good. So let's see if any of our PC are getting DHCP IP from this router. Fantastic. So it's getting a DHCP IP. So we should be able to SSH to it once we configure our SSH. So let's go back to the slide. So steps to configure SSH on our Cisco router and switch. Click on the router or switch and access the CLI, which is what I've done. And the first command is enable. Then enter the global configuration mode, which is configure terminal. So we come here. So let's start afresh again. Go to the router. This is our router. And CLI. This is the CLI. I already configure a host name for this router. But so that it could be simple, let's configure a new host name for it. Let's call it LAN router. So how do I configure host name? Host name, LAN router. So the name should change from Network Kings IT Solutions to LAN router, because I want to follow the documentation we have here. So we said set the host name and then the domain name. So we said the domain name required for SSH, very important. So we look at the command for host name. We say host name LAN router. And what is the command for the domain name? Is IP domain name. Sorry, I'm going to have to edit that. So the command is for us to configure the domain name is IP domain name. Domain name. So we call it Network Kings IT Solutions.com. You can use any domain name. So we've configured the domain name networkingsitsolution.com. Then we generate the RSA key for SSH 2048, which is 2048 bits recommended. So you're going to see how we configure that. What is the command? Crypto key. The command is crypto key generate RSA. So we go back to our router again. So crypto key generates RSA. So when we generate it, we said we should use 2000. So now look at it. Very important why you should create the username, the host name rather, and the domain name. You can see now I said the name for the key will be LAN.router.networkkingsitsolution.com. So now I said you should choose from 330 to 4096. So I'm going to use 2048. Some people can use 1024, just as you desire. So we can confirm that, generating 2048-bit RSA key. Keys will be non-exportable. So we move on. So it tells us that what? It said SSH 5 enabled. So just give me some moments. Yeah. So SSH 5 enabled. Let's look at our configuration again. Now create a local user account with a username and password for SSH login. So if I want to log in from any of the PC, I need to create a username and a password to log in. So I am creating a username of admin and giving that username privilege 15 and secret Cisco at pass. So let's create a username. So we say username admin. We give it a privilege level of 15. And we say secret. What's the difference between secret and password? In your password, if you configure just ordinary password, it's not going to give you an hash value. But for secret, it's going to give you an hash value for that password. So username admin, privilege 15, and the secret, we now put our password Cisco at pass. So we've configured that. The next thing is for us to enable SSH and specify the version. So we can say IP SSH, then version. We have two versions, version 1 and 2. 2 is more secured. So once we've done this, we now need to configure the line VTY. This is the virtual terminal line. Now, what is this one saying? How many devices can log in concurrently on this using the SSH to this router? Like we have 4 PCs here now. We can configure it that 4 PCs should be able to log into these devices, this router, using the SSH, which is the line VTY. So we come in config T line VTY. Now, if we look at the line VTY, is 0 to 15. That means we have 16 users or 16 devices having the capacity to log in concurrently on that router. But let's just make for 4 or for 5. That's 0, 1, 2, 3, 4, making it 5 users. So transport input. So now if you say all is going to take both both telnet and SSH. If you look at the SSH here now, you will see that it is using what? TCP IP SSH protocol, which is what we studied tonight. TCP IP suite. The same thing with telnet. What is the difference between telnet and SSH? Telnet is not secure, while SSH is secured. In other words, whatever you are sending through your telnet is always encapsulated. So it is not sent as transparent data, but telnet send it as transparent. So input, some people will say all, but if you are configuring all, it means anybody can use telnet too to log in, and then we have access to your device. So SSH, we say input SSH, and then login local. So let's see our data again. So line VTY 0 to 4, transport input SSH, login local, then exit. So now we can go to our PC and check. Let's look at PC1. In PC1, IP config, let's see the IP on PC1. The IP is 192.168.200.11. So, and the gateway is 200.1. Can I ping my gateway 200.1? Yes. So can I SSH? The command is SSH -L. The username that we configure is admin. Then the IP 192.168.200.1. You see, it's asking me for password. So the password is Cisco at pass. Now it says error, so let's try again. Cisco. Yes, now we are inside our router. Can you see this now? Show IP interface brief. Now we are inside the router. We can now even see show SSH. If you look at it now, you can see in the show SSH who is the username. You can see that the user person that is logging is admin. And section has started in and out. Now, I can go into PC2 and try to log in from PC2 as well. SSH -L admin 192.168.200.1. Okay. So now we need to confirm, does this PC have IP address config T? No IP. So let's go and make sure it's getting an IP via DHCP. Our DHCP is already up and running. So this is .12. So fantastic. That was why we were unable to SSH in. Let's check the IP again. It has .12. Now let's try to log in. Password again. Cisco. I know we didn't get the password correct. So try again. Cisco at pass. Okay, Cisco at pass. We should be in. Okay, it says connection failed. Let's go back again and try to log in. Now we are in. So let's do show SSH again. Now, can you see the number of login now? The 0. Now, our line VTY, remember the line VTY is 1 to 4. So this is the first one in and out. The first device has logged in. This is the second device that has logged in now. Now, where I'm going is you will see what will happen when we want to connect the fifth device. Does this PC has an IP address? No. Let's go and ensure it has an IP address. So, again, it should have 13. SSH-L admin 192.168.200.1 Cisco at pass. So let's do show SSH again. You can see that we have this 0, 1, 2. So we're going to the fourth one. ipconfig SSH-L admin 192.168.200.1 Cisco. So show SSH. Now we've seen 0 to 3. So we have 4 already. Let's try to connect 2 more PCs and see what will happen if we decide to have more than the 5 users that we want to create, that we created on the line VTY. So we get this, see whether it's going to take IPv DHCP. Obviously, it should fail at the first attempt because the port is still trying to, go through the listening and forwarding state. Once it's able to forward and is able to contact the DHCP server, then we will be good to go. So let's try again now. It's going to go .15. So we get this SSH-L admin 192.168.200.1 and Cisco at pass. We are in. So if we do show SSH again, now we have completed the 0 to 4 users that we created. As a matter of fact, if we come into this and do show SSH, you can see all the users are here and the sections are started and all of them are on. Now let's try to log in again now on the next user here. Let this user also pick IP. Should be .16. Fantastic. Then we ping. Let's even do the SSH-L admin 192.168.200.1. You see, connection refused by host. Are you seeing this? Even though we are able to ping it, but because we have exceeded the number of users that is to log in. See, so now because we've exceeded the number of users, It's not allowing us to SSH. He said connection refused by remote host. It's not giving it the opportunity. It's not allowing it to log in on the. Okay. So he said, no way, you can't. But let's log out of one of the. So if I exit here, remember I've logged out now. And if I try to now log in here, let's see what happens. You see, I'm able to log in now because I only permitted only 5 users. Once the sixth person comes, it's going to be disconnected. The router won't allow it. So you could create that it's only one PC, maybe your own, or you and your boss in the office that should be permitted the SSH or any remote connection to that device. Do we have any question? With this, we've come to the end of today's class. Like I said, I don't want to be keeping our classes more than 45 minutes, at most an hour. Do we have any question?
No, sir.
Okay, thank you. If you have any question, you can, if you cannot talk where you are, you can drop a message. I'm going through our chat now. Okay, somebody said good evening. Good evening. Thank you too. All right. If you have any question, all right. If there is no question, is anyone raising the hand? I'm just coming. Okay, no hand is raised. So are we saying that we understand how to set up SSH now? Okay, somebody is raising the hand. Mr. Akinloye. Okay, please go ahead. Ask your question.
Yes, sir. Thank you so much for the class, by the way. So I asked a particular question the other time regarding setting up a networking route for WhatsApp application. So I'm now thinking of a way of, okay, does it mean that setting up of either TCP or UDP networking system, does it mean it can only be used premise, like on physical server, um on the physical server? Like what I mean by this is that, for an instance, WhatsApp, do they also go through this route while setting up their networking as well?
Okay, so WhatsApp
And
is just okay. Are you done with your question? I'm listening.
no, the other, also, what are the main use case? Like, I mean, the main use case scenario of this setup,
Okay,
or this protocol?
okay. So for newbies into tech, if you are going to be doing network engineering, if you are going to be a network engineer, some of your servers are going to be hosted in the cloud, maybe in India, maybe in UK. So if you want to log into that server, do you have to now travel to UK to go and log in and configure things? No. So what you do is to configure SSH in that router, in that server, so that you can remotely log into that server anytime you want to access it from anywhere in the world. That is the use case for SSH. Your routers, you have some router in Abuja, you have some router in Ikeja, you have some router, you don't have to be going to each of those routers. Now, you can see that I'm accessing this router now from any of these PC over the network. The same thing if this router is sitting in USA. So far I know the IP and SSH is configured on that router, I'm going to access it remotely. Do you get that?
Yes, sir.
All right. Any other question, please?
I have some questions regarding the WhatsApp.
Yes, so I said for WhatsApp, what happens about WhatsApp is the fact that WhatsApp is just one application out of many infrastructure that's what do we call them now? Meta, right? Meta has its own infrastructure. They set up a massive network. So WhatsApp is just one of the applications that run. They have other applications like Facebook. They have other applications like Instagram, all other applications like that. There are some applications that they run that we don't even know because it's not popular. So don't restrict, how TCP or UDP works to just WhatsApp. No, WhatsApp is just a single application. But what are the protocols that enables WhatsApp to work? That is where TCP comes in. That is where UDP comes in. Okay? Do you get that?
Yes, sir. Yes, sir. Thank you, sir.
All right, you're welcome. Any other question? So if you have no any other question, thank you everyone for coming to class tonight, and do have a wonderful night's rest. It's going to be uploaded, the class is going to be uploaded tonight.